here we're trying to find the surface area of the portion of the cylinder that's going to be above the triangle in this X and Y plane. Well, let's try to draw this out. So it's technically supposed to be like a 3D graph, but we don't have any Z's here, so I'll just keep it as a 2D for now. But we have 0, 0, 0, and then 0, 1, that's going to be in the Y, 1, 1, it's going to be 1 and 1. So essentially we've just got that line, and this line, and this line. And then if we were to try to figure out what that cylinder thing is, well, let's imagine this. If Y was 0, then Z would be 1. So let's even draw a third axis right here. Here's our triangle. And if Y was 0, then Z would be 1. And if Y was 1, then Z would be 0. So Y being 1, Z equals 0. So we see we get this little arch like this. And here's your triangle. And if you want to put those two together, just go back to this one and imagine it curling over like this. Great. So now we've got the shape in mind. And let's try to figure out the surface areas. We know we can use the ds equals the square root of fx squared plus fy squared plus 1 dx dy. Now dx and dy is pretty easy because we're just going to have on the outside the dy. And if we would go to dy, that would be from 0 to 1, right? So we can just easily put that there. And then we're going to have the formula inside. Well, let's try to figure out what that is. Here's dx and dy. Okay, so fx is going to be equal to, we're going to look at this. Fx is just 0. There's no x's there. And fy is going to be equal to negative 2y. Okay, so if we put the square root in there, we're just going to be getting 0 squared plus, if we square that stuff, we're going to get 4y squared plus the 1. So it's just going to be 4y squared plus 1 as far as the integral goes. Now this is going to be for dx. Let's figure out what our x limits are. So I'm going to draw a line right here that's going to represent one of the small millions of lines that I'm going to go from here being a really small line to a much bigger line there. And I'm basically going from the x being 0 all the way to this side, and we're going to figure out what this line is. Isn't this line just going to be, if this was 0, 0, and that's 1, 1, then we know the slope of this line is y equals x. So we're just going to go x equals y. That's going to go from 0 to y here. Great. So now let's try to do this integral for the dx. It's really easy for dx, so we just stick the x in front because this is just for 4y squared plus 1. We didn't do any calculations or integrations there. But this is going from 0 to y, so technically we'll replace the x with the y. So we'll go y square root of 4y squared plus 1. And we're integrating that from 0 to 1 dy. Now this is my favorite kind of integral because look, we got the derivative of the inside is sitting on the outside. We got the y squared in here and we just got a single y sitting out there. God, this is easy as hell. All we're going to do is go 4y squared plus 1. This turns into a 1/2 over there, and we'll have a y there, right? We'll directly integrate this by adding 1 to this, and then dividing by the reciprocal, so we got 2 over 3. And then we'll multiply the bottom side by the denominator, or the derivative of what's in here. So we'll get 8y on the bottom. Delete these things, that'll be 4 on the bottom. So we're left with 1/12 times 4y squared plus 1, 3 over 2, and this is going from 0 to 1, so we could see that this will just be basically 5 to the 3 over 2 minus 1 to the 3 over 2 multiplied by the 1 over 12, which will simplify down to be 1/12, and then 5 square root of 5 minus 1. Nice and easy.